Namaste, fellow Java developers. Welcome back to our channel. Today, we are diving into a super exciting topic, blockchain basics for Java developers. Have you ever wondered how cryptocurrencies like Bitcoin work or how data can be stored securely and transparently? Well, blockchain is the answer. In this 5-minute tutorial, we will break down the fundamental concepts of blockchain and show you how to build a basic version using Java. By the end of this video, you will understand the core components of a blockchain, how blocks are linked, and how immutability is achieved. This is a foundational skill that can open doors to many innovative decentralized applications. So, grab your favorite beverage, get ready to code, and let us begin our journey into the world of blockchain. Alright, let us start with the very first building block of any blockchain, the block itself. Imagine a block as a digital container for information. Each block contains several key pieces of data. Firstly, it holds the actual data you want to store, like transaction records. Secondly, it has a timestamp indicating when the block was created. Thirdly, and very crucially, it contains its own unique digital fingerprint called a hash. This hash is generated from all the data within the block. If even a single character in the data changes, the hash will change completely, ensuring data integrity. Lastly, each block also stores the hash of the previous block in the chain. This is how blocks are linked. On the whiteboard, you can see a simple Java class representing our block. Notice the fields for data, timestamp, previous hash, and its own hash. The calculate hash method uses SHA-256 to create that unique fingerprint. This method takes all the block's data and computes a secure hash, which is fundamental to blockchain security. Now that we understand what a block is, let us see how these blocks come together to form a blockchain. A blockchain, as the name suggests, is simply a chain of these blocks, securely linked together. The magic happens with the previous hash field we discussed. Each new block added to the chain includes the hash of the block that came before it. This creates an unbroken, tamper-proof chain. If someone tries to alter a block in the middle, its hash will change, which will then invalidate the previous hash of the next block, and so on, breaking the entire chain. This is the core principle of immutability in blockchain. Our whiteboard shows a blockchain class in Java. It contains an array list to hold our blocks. The addBlock method is responsible for creating a new block, linking it to the latest block in the chain by setting its previous hash, and then calculating its own hash before adding it to our list. The first block in any blockchain is special. It is called the Genesis block and has no previous block, so its previous hash is typically an empty string or zeros. Time for some practical application. Let us put our block and blockchain classes into action and build a mini blockchain right here in Java. On your screen, you can see a simple main method that demonstrates how to create and populate our blockchain. First, we instantiate our blockchain object. Then, we create our very first block, the Genesis block, with some initial data, for example, Genesis block data. We add this to our blockchain. After that, we create subsequent blocks, each containing different data, like transaction 1 data or transaction 2 data. Notice how each new block automatically gets linked to the previous one through its hash. We then iterate through our blockchain, printing out the details of each block, including its data, its own hash, and the hash of the block before it. This allows us to visually inspect the chain and confirm that each block correctly references the hash of its predecessor. This is a simplified example, but it clearly illustrates the chaining mechanism that forms the backbone of any blockchain system. As you begin experimenting with blockchain, it is common to encounter a few pitfalls. One common mistake is neglecting to properly validate the chain's integrity. Always ensure that the previous hash of the current block truly matches the hash of the preceding block. Another mistake is using weak hashing algorithms or not properly including all relevant data when calculating a block's hash. This can compromise the security and immutability of your chain. A third pitfall is not handling the genesis block correctly, leading to errors when the chain is empty. To avoid these, here are some best practices. Always use strong cryptographic hash functions like SHA-256. Rigorously validate the entire chain from the genesis block onwards when adding new blocks or verifying existing ones, and clearly define the structure and initial state of your genesis block. Remember, the strength of a blockchain lies in its unbreakable links and cryptographic security. And that brings us to the end of our quick dive into blockchain basics for Java developers. What did we learn today? We understood that a blockchain is a secure, linked list of blocks. Each block contains data, a timestamp, its own unique hash, and the hash of the previous block. We saw how these previous hash pointers are crucial for creating an immutable chain, making it incredibly difficult to tamper with past records. We also built a simple working example in Java, demonstrating how to create blocks and add them to a chain. This foundation is essential for understanding more advanced blockchain concepts like consensus mechanisms, mining, and smart contracts. Now it is your turn. I encourage you to experiment with the code, modify it, and try to add more features. Practice is key to mastery. If you found this tutorial helpful, please give it a big thumbs up, share it with your friends, and do not forget to subscribe to our channel for more exciting Java programming tutorials. Keep coding, and I will see you in the next video. Jai Hind.